Is ReScript output optimized by default? If you're reading through the docs, you're certainly left with that impression. In this video, I benchmark JavaScript and ReScript output to see if those claims are true. Do the claims match reality? So let's examine the claims. So in the docs, there's a section on performance. It has the heading faster than JavaScript. When we look at the details of that section, it says that ReScript's type system and compiler naturally guide you towards writing code that's very often performant by default, leveraging optimizations. And in the following paragraph, it references this JavaScript adage that typically if you want to write good JavaScript code that's performant, that you write it as if there is a type system, because there are certain optimizations within the V8 engine that generate performant code if you write code in this way, if you write JavaScript code in this way. The reasoning is that ReScript gives you a very strong type system, and so when it compiles to JavaScript code, it's within this framing of a strong type system in ReScript, and so it will lead to a code that's friendly to optimization by default. So all of this is a little bit vague, and it really requires us to put things to the test to see if the claims are true. So let's go ahead and do that. Secondly, I want to be upfront about the sources of inspiration. So we're going to do one set of benchmarks with Dino, following inspiration from Beyond Fireship, and in particular this video, they do some array summing in 4 different ways. We're just going to do the exact same thing in JavaScript and in ReScript and benchmark it using Dino. And then the other set of tests that we're going to do draw inspiration from this particular blog here. I'll link both of these in the description, by the way. And it references, in particular, an example that encapsulates hidden classes, inline optimizations, and preventing de-optimizations. So those 3 concepts are covered in this blog post. Thirdly, let's go through our setup. I'm on a Mac OS. I am using ReScript 11 and ReScript Core 1.6. And let's go through the folder structure. I have a source folder with JavaScript and ReScript subfolders. They contain the tests that I had just referenced. Let's take a look at those. Summing in loops, for example, we have various ways in which we try to iterate over an array and sum things: for loops, for of loops, reduce, and for each. So we're going to look at the performance and benchmark those. And secondly, we have this hidden classes. We have a way of basically creating instances of this point object. One involves adding properties in a fixed order, which has a way of representing hidden classes in a consistent way in the optimization in the V8 engine. And then we do them kind of out of order, which breaks that optimization. And so we're going to benchmark those. Secondly, we have this ReScript folder where we have the same set of tests for creating loops and summing over loops. We're going to do that 4 different ways. That's going to output a sum and loop res.mjs file where we have the output in JavaScript, and we're going to test the performance of that. And then we have the same hidden classes test where we are creating objects in a way that triggers the optimization, or that would mirror the JavaScript code that's output. And we're going to see what kind of JavaScript is output and if that code is optimized. If you've been enjoying my channel, make sure you like, subscribe, and sign up to my newsletter. Folks who sign up to my newsletter will get timely notifications about my videos as they come out, and access to my personal email. So the first thing that we're going to benchmark is the sum and loop, the various ways that we're summing in JavaScript loops. So this is straight up copied from Beyond Fireship. It's the 4 cases: for loop, a for of loop, a reduce, and a for each. And we're just going to go ahead and run those benchmarks for those 4 tests. So let's go ahead and do that. So we've set the baseline to be the for loop because that's known to be the fastest, and as expected, there are the other 3 are orders of magnitude slower. Let's go over to the equivalent sum in loop file, where we have actually noticed just in the setup that we are there's only really 3 ways to represent this in ReScript. There's no for of iteration that I could find. And so we have our reduce function, our for each function, and our traditional for loop. Now, when we take a look at the generated code, initially it's not what I expected. I thought there would be some optimizations to perhaps convert these all into for loops, but that's not the case. But we're going to just run the tests anyway and just see what the benchmarks say. Okay, so let's run those tests. Right, so as expected, we have the for loop, which is the fastest and is the benchmark base, and the others are orders of magnitude slower. So that's not good. So we have to kind of sum what's happened here. We have written a for loop, summing over for loop in ReScript. We expected ReScript to guide us towards optimized code. Doesn't look like that's the case. Okay, let's go over to our JavaScript code, and we're going to look at optimizations based on the V8 engine and hidden classes. So we have 4 different functions, one for creating this point object, and then one for adding props in a way that is fixed and orderly so that optimizations can occur in the V8 engine, and others where there's a little bit of randomness so that the properties, the order in which they're modified is out of order based on some random value. And then we have what they call a hot access function, which accesses these elements, basically sums up the 2 values A and B, and accesses, and that's where the optimizations would be triggered within the V8 engine. Okay, so let's go ahead and run these hidden class optimization tests. So our baseline is, so we've created 10,000 objects and 10,000 basically another 10,000 iterations over each one. And we can see that there is a little difference between the code that is optimized and not optimized for the V8 engine. I'm just going to run that again just to be sure. And of course, we can experiment a little bit with the size with the number of objects that are created, because of course these optimizations are best measured over a large amount of objects and iterations. All right, now let's go over to our ReScript folder, and we're going to take a look at this code. It's very similar to the code that we wrote before, where we have a function to create the object. We have a method that modifies them in order consistently, A and B properties, and then we have an equivalent function for basically to introduce some randomness in the order in which they are the properties are accessed or modified. And this all has to do with this is what will trigger or not trigger the optimizations in the hot access loop, in this hot access function, where we go over in a loop and we add A and B together. So let's go ahead and run that optimization. Okay, so here we have a bit of an unexpected result where the random order, the way we've written the ReScript code with random property access and the order in which they're modified has not resulted in output code that is optimized by default. Okay, so let's take a look at that output code a little bit, and we'll notice that if we take a look at it, it's kind of written, it's no surprise because it's just kind of written the same way as we would to write either optimized or not optimized JavaScript code. So that is interesting and a little bit not expected. Okay, so let's go back and examine the claims once more, and perhaps we can get a little bit of insight as to why our tests didn't work the way that we thought that they might work. So when we look closely beyond just the buzzwords of optimization and optimized by default, faster than JavaScript, and just the general buzz around optimization, we can see that what they're trying to tell us is that when you write in a type system, and when you write in ReScript, which has a type system, it's more likely that you're going to write properly structured JavaScript. And then if you write code that is properly structured because of ReScript, then the output code will be properly structured, and those optimizations will likely be triggered in the V8 engine. So you kind of have to look through the buzz, I think, on this a little bit. There's a little bit of buzz. You can't just, when I read this, I thought, great, it's optimized. It's just like it does a lot of optimizations for you. That's one thing you don't have to think about. Not exactly true. You really have to take a look at the documentation and read it through to understand really what it's trying to say. And what it's trying to say is this, is that ReScript has a type system. And that's why you are likely to write optimized JavaScript code. But there is no conversion, for example, if you have, if you're writing in a way, if you're looping in a way that is suboptimal, there's no optimizations to perhaps like transform that into a for loop underneath the hood, which is too bad. But that's the way it is. Thanks for watching. If you'd like to see more of next-gen web development languages and explorations and topics like this, then like, subscribe, and follow me on the journey. Bye now.